Question number 7, February, March 2019, paper 4, variant 2. We have a frequency table, a grouped frequency table, which shows 20 students who have recorded the mass of their pencil cases. I don't know why anyone would want to do that, but anyway. The table below shows the results. You got 2 of the students. Their pencil cases had a mass which was between 0 and 50 grams. And there were 5 other students. The mass of their pencil case was between 50 and 100 grams, and so on and so forth for the rest of the table. They've asked us to calculate an estimate of the mean mass. Now, the reason why they use the word estimate here is because we don't actually know the exact mass of these pencil cases. We know 2 of them were somewhere between 0 and 50 grams, but we don't know the actual mass of those 2, nor of these 5, nor of these 4. These 4, for example, we know their mass was somewhere between 100 and 125, but we do not know the exact values. So what we need to do here is we need to estimate what mass these 2 were, and what mass these 5 were, and what mass these 4 were. So the fairest way to do that is to find what is called the mid-interval value. Okay, the mid-interval value, which we're going to call x. Okay, so the mid-interval value is a halfway between these 2 values. So you just add them together and divide by 2, and we can see for between 0 and 50, we can say it's 25. So we say that these 2 pencil cases, we don't know what their mass was, but we know that the mass of these pencil cases was somewhere between 0 and 50 grams. So let's just take the halfway point. Okay, that's the best we can do. All right, it's just an estimate now. And we have 5 pencil cases somewhere between 50 and 100. So halfway between 50 and 100 is 75. If you're not sure how to do that, you just add them together. You say 50 plus 100 divided by 2. That's 150 divided by 2 gives you 75. That's how you find the mid-interval value. So halfway between 100 and 125 is going to be 112.5. Okay, that's 225 divided by 2. And then you're going to have halfway between 125 and 150. Well, that's 175 divided by 2, which I think is 137.5. Let's just confirm that. So you have 125. It's a bit too big, this thing. 125 plus 150, okay, divided by 2 gives you 137.5. okay, 137.5, just to make sure. And between 150 and 200 it's going to be 175. Okay, that's 350 divided by 2, 350 divided by 2, just to make sure of that. Okay, so you're going to have 350 divided by 2 gives you 175. Okay, so now to find an estimate of the mean, we can now do the following. This is a frequency, and this is an estimate of the mass of, the items that are in that particular group. So we can say that there were 2 pencil cases whose mass we've estimated to be 25. So the estimated total mass of these 2 pencil cases will be 2 times 25. And then we got 5 pencil cases whose mass was estimated at 75. So there's 5 times 75. We'll give an estimate of those 5 pencil cases. And there were 4 pencil cases whose mass was 112.5. So you 4 times 112.5. And then there were another 6 whose mass was 137.5. And another 3 whose mass was 175. Okay, and all of that, you're going to divide it by the total number of pencil cases, which is, there's 20 students who found the mass of their pencil cases, that's 20. Okay, the mistake people make here is they divide, they say, oh, there's 1, 2, 3, 4, 5, things like that, because there's 5 categories, you've got, all right, 5 here. No, this is the mean of something is the total sum of all those things divided by how many items there were in the first place. So here we're finding the total sum of the masses of all these pencil cases divided by the total number of pencil cases. So 2 times 25 plus 5 times 75 and so on will give us the total sum of all the masses of all the pencil cases. Divide that by 20, and you divide it by the number of pencil cases there were, and that will give you your mean. So be very careful now when you stick this into your calculator, not to make a mistake. It's very easy to make a mistake here. So I'll write my fraction bar and I'll put 2 times 25 plus 5 times 75 plus 4 times 112.5, okay, plus 6 times 137.5, okay, plus 3 times 175, and that's all divided by 20, and that will give me my mass, which is 111.25. Now 111.25 is an exact value. I don't write 111 rounded to 3SF because it's an exact value, okay? So there's no need for you to round it. It says in the beginning of the paper, if we go back to the beginning of the paper, it says, just to show you, hold on, go all the way back to the beginning of the paper, it tells you here, oops, it tells you here that, yeah, if the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures, okay, and for degrees 1 decimal place. So that answer we got is counted as an exact answer because it was 111.25. Okay, it was 111.25. Stop there, didn't continue. Exact answer, you can leave it like this, it's perfectly fine. Okay, now question part 2 says use the frequency table to complete this cumulative frequency table. Now cumulative frequency table is basically where you are finding how many items are in the group from this point all the way back to the beginning again. So for example here, there are 2 pencil cases whose masses are between 0 and 50. So the number of pencil cases in total whose masses were less than 50 is 2. And there were 5 pencil cases whose mass was between 50 and 100. So the total number of pencil cases whose mass was less than 100 from 100 all the way back to 0 was this 5 plus this 2, which is 7. Because in total there's 7 whose mass is less than 100. From 0 to 100 it means. And here it means from 0 to 125. So you can see the pattern, you have to just keep adding the number. So that's 11 altogether. You got 4 plus 5, okay, which is 9 plus 2, which is 11. And then you got another 6. So 11 plus 6 is going to be 17. And then, of course, the total has to be the same as the total number of pencil cases in the whole survey. So there's going to be 20 in total whose mass was less than 200, okay, which is upper limit. All right. So then it says a student is chosen at random. Find the probability that this student has a pencil case with a mass greater than 150 grams. Okay. So the mass greater than 150 grams, there are 20 students out of a total, greater than 150 grams. All right, I have to go here. Okay, that's confusing. Greater than 150 grams is basically the last 3 here, right? The last 3. So there's 3 out of 20 altogether. Okay, so you have 3 out of 20, all right, whose pencil cases will have a mass greater than 150 grams, okay? The last 3 in here. It's easy if you look at the frequency table for that. Okay, so this 3 in that category out of a total of 20. All right. Okay, so part B, some students each record the mass M in kilograms of their school bag. Looks like they've got nothing better to do than weigh their bags. Adil wants to draw a histogram to show this information. Complete the table below. Okay, so 32 of the students had bags whose masses were between 0 and 4 kilograms. Between 4 and 6, between 6 and 7, we don't know how many students had masses of the bags of masses between those, and that's what we have to find in this question. And between 7 and 10 kilograms, we had 42 students who had their bags that had that mass. Now, what they have told us is that the height of each of the bars on the histogram that was drawn to represent this information. Okay, and as we should know, in a histogram, it is the height of the bar which represents the frequency, okay, which represents, the frequency density. Okay, not the frequency, sorry. The height of the bar represents not the frequency, but what's called the frequency density. The frequency density is what's on the vertical axis of a histogram. So when you have a histogram, the vertical axis is not the frequency, it's the frequency density. Okay, the frequency density. And here the mass of the bags will be on the x-axis. So the height of the bar is not representing the frequency, rather it's representing what's called the frequency density. So what we need to do here is we need to find the frequency density for those things that we are able to find it for. For example, we know the frequency and the mass for this first and this last category. So for those we can find what the frequency density is. Okay, the frequency density is what helps us to make the area of the bar proportional to the frequency. You see, it's the area of the bar that's proportional to the frequency in a histogram, not the height of the bar. The height of the bar is proportional to the frequency density. Okay, the frequency density is equal to the frequency divided by the class width of the interval. So here the frequency density is going to be 32 divided by 4. 32 divided by 4. 32 divided by the width of this bar, that gives you 8. So that's the frequency density for the first bar. For the second bar, the frequency density we don't know, nor for the third. We can't find that because we don't know what the frequencies are. Okay, but for the last bar, the frequency density is 42 divided by 3. 42 divided by 3, okay, because the interval here is 3, from 7 to 10. That gives you 14. 3 times 10 is 30 plus 12, yeah, gives you 14. Okay, so now we need to get this information to help us work out the frequency of these bars. So first of all, I know the frequency is equal to the frequency density times the interval. Okay, so if I can find the frequency density for these two, I can then multiply that by the interval and I'll get the frequency. Okay, so that's what I have to do here. So what I'm going to do is this. I'm going to call this x, I'm going to call this y. Okay, I know that, okay, for this bar, all right, the frequency density is 8 and the height of the bar is 1.6. So I know that the frequency density 8 is being represented by 1.6 centimeters of the height of the bar. The height of 1.6 represents the frequency density of 8 units. So 8 units is being represented by 1.6 centimeters. I want to know, okay, how many units of frequency density is being represented by 2 centimeters. Okay, so I end up with getting myself a little equation here. So I can say x is equal to 16, 8 times 2 divided by 1.6. Okay, 8 times 2, cross multiplication. 16 divided by 1.6 is equal to 10. Okay, so I can see that this is going to be a 10 here. Okay, sorry, not there. That's a 10 down here. So x is 10. Okay, so this here is now a 10. Okay, so I know that this is 10. Okay, that was what we called x. Alright, now, so I can see that there's a proportion here. We could have worked this out before. So the proportion is as follows. Okay, that the frequency density is always 5 times, okay, it's always 5 times the height of the bar. See, 1.6 times 5 gives you 8, 2 times 5 gives you 10, 2.8 times 5, well, that gives you 5 times 2 is 10, and 5 times 0.8 is 14. So 1.2 times 5 is going to give you this. So 1 times 5 is 5, and 0.2 times 5 is 1, so it's 5 plus 1, which is 6. So y is equal to 6. Okay, so now I know what the frequency densities are for these two bars. I can work out what the frequency is. I can just multiply the frequency density by the interval. See, frequency density is frequency over interval, so frequency is frequency density times interval. So it's 10 times 2, the width of the bar here is 2. 10 times 2 is 20, and here you've got 6 times 1 is 6. Okay, 6 times 1 is 6. And there we have our frequencies filled in. So we completed the table, and now we move on to question, I think 7 part C. Now, it's got 2 parts to it, has it? 1, 2, 3. Okay, so now the frequency table below, now this is not a grouped frequency table. Here we have all the data values. There's nothing to estimate here. We know that there's 2 books that were read. Okay, so no books in a reading marathon. Okay, so 2 people read 1 book, 2 people read 2 books, 16 people read 3 books, 9 people read 5 books, and so on. So we know exactly, how many books were read by how many people, except for one that's missing here. Okay, we don't know how many people read 7 books. Okay, but we know that the mean number of books is 4.28, and we've got to find the value of x. So to find the mean here, this is a frequency, and this is x. There's no estimating x. We know exactly what number x is here. So what we've got to do is we've got to do f times x. Okay, the frequency times the number of books. So there was 2 people who read 1 book, that's 2 books that are read. 2 other people read 2 books, that's 4 books that are read. 16 people read 33 books, that's going to be 48 people, 48 books that are read. 40 books were read by these 10 people altogether. 9 5s are 45 books were read by these 9 people altogether. 4 6s are 24 books were read by these 4 people. Now there's x people that read 7 books, well that's 7x books that were read by those people. Okay, and 2 people read 8 books, that's 16 books. So if I add these all together, so if I do 2 plus 4 plus 48 plus 40 plus 45 plus 24 plus 7x plus 16, and if I divide that by the total number of people, okay, they don't tell us how many people, so we're going to have 2 plus 2, okay, that's 4, plus 16, that's 20, that's 30, that's 39, 39 plus 4 is 43, plus 2 is 45, so we're going to have 45 plus x is the total number of people. So this is the total number of books. Okay, this is the total number of books, the number of books, okay, that were read, divided by the number of people, and that will give you the average number of books read, the mean number of books read, and we know that that's going to equal 4.28. They've told us that the mean is 4.28. Okay, now let me just make sure that I'm right here. 2 plus 4 is 6, 15, 25, 35, 41, 43, 45. Okay, that's all right. So now we're going to add these numbers on top together. Okay, I'll just stick it on the calculator. There we are. So we're going to have, just move this out of the way. You can see all the numbers properly. Okay, so we're going to have 2 plus 4 plus 48 plus 40 plus 45 plus 24 plus 16. Okay, was there anything else there? No. Okay, and that gives us 179. So you have 179 plus 7x. So 179, and then you got your plus 7x, which you can't add to that because they're not like terms, and divided by 45 plus x gives you 4.28. Okay, 4.28. Now we've got to solve this equation. Okay, so we have to multiply both sides by 45 plus x. Okay, so you end up with 179 plus 7x equals, and you got 4.28 times 45. So you have 4.28 times 45, and that gives us 963. That gives us 192.6, 192.6 plus 4.28x. Okay, and now I'm going to bring the x's to one side, so I'll do 7x minus 4.2x. Oops, 7x. So I have 7 minus 4.28. Oops, supposed to be a 4 here. That gives us 2.72. So on this side I have 2.72x. I'm running out of space here. 2.72x is equal to, let me just tidy that up, pen's messing up here a bit. So 2.72x, okay, is equal to 192.6 minus 179. So you have 192.6 minus 179. That's correct. That gives us 68 over 5, which is 13.6. So 13.6 divided by 2.72 should give us an answer. So x is equal to 13.6 divided by 2.72 gives us 5. Okay, it looks like that's correct because it's an exact answer, 5. Okay, so that's the value of x. It has to be a whole number because otherwise you can't have, you know, a number of people that is less, that is not an integer. It has to be an integer, a positive integer. Okay, so then it says write down the mode. Now the mode is going to be the middle, the number of books read which was read the most frequently. So the number of books that were most frequently read. You can see here this is 5, so you can compare them all now. So 16 is the frequency which is the highest. That means this 3 is the mode because it was the number of books read the most frequently. Okay, 16 people read 3 books. No other, you know, there were no other number of books read more frequently than 3. So 3 is the mode. Okay, 16 is the frequency. Okay, the highest frequency. So 3 is what corresponds to the highest frequency. Okay, so the number of books that corresponds to the highest frequency is the mode. Then it says write down the median. Now the median is the middle term when they're placed in order of size. Okay, so we can see that here, the total number of items. Okay, we have 45 plus 5. There's 50. Okay, so the 50 items altogether. So there's 50 people that were reading. There was 50 people that were reading. Okay, so we want to find the middle term is the number of books read by the 25th person. Okay, when they're put in order of size in terms of how many books they've read. Now these are already in order of size because you see it goes 1, 2, 3, 4, 5, 6, 7, 8. So we can see that we're looking for the 50th person. So if you count along here, you're going to have 2 people. Okay, they would have read 1 book. Then the next 2 people read 2 books. So when you got to the 4th person has read 2 books. Then the next 16 people, that's now you're on the 20th person, okay, has read 3 books. And the next 10 people, now you got to the 30th person, they've read 4 books. So that means the 25th person must have read also 4 books. Okay, so the median is the middle term, okay, when they're in order of size. Okay, so 50 is basically going to be 50 plus 1 divided by 2 when you got like exact value. So 50 plus 1 divided by 2 gives you 25. Okay, 26 divided by 25.5. So we're looking at actually for the 25th and the 26th person. Okay, and both of them are in this category here. Okay, because the 20th person read 3 books, the 30th person read 4 books, the 25th and the 26th person must have read 4 books. Okay, the 25th and the 26th. See, this tells us where the median is, and what it is, okay, is what corresponds to it. So 50 plus 1 over 2 gives you 25.5. That means the 25th person and the 26th person, we're looking to see how many books they read. And both of them read 4 books. So the median is 4. Okay, so that's the answer for that. Okay, and there we finished with this question, I think. Okay, thank you for paying attention.